Okay, if we talk about the question related to the electricity and magnetism, so the first question is that figure shows a solenoid connected to an ammeter, right? There is a solenoid
Yeah.
connected to an ammeter, and in question they mention that the south pole of a permanent magnet moves into the left hand of the solenoid, as you can see in the diagram. It is going inside the solenoid. So the ammeter reading shows that there is a small positive current in the circuit, right?
Yeah.
So explain why there is a current in the circuit when the magnet moves.
Because like when a magnet passes through an like a solenoid, there is like a magnet induced electromotive force in the circuit.
Okay. So basically, we already know when magnet moves into the coil, the magnetic field lines or last time, if you remember, we used to write the magnetic flux linkage, right?
It's like
Or the magnetic flux linkage. Changes. And due to the change, an EMF
it's like
will induced in the coil due to induction. So an ammeter right? So EMF will induced over there, and due to that EMF, coil will deflect, and that will show you the deflection in the circuit, right?
yeah.
And when the magnet is inside the solenoid, it stops. So when magnet is inside, it stops moving. It is then pulled back out of the solenoid. So when we are moving into the coil, so then we stop that magnet and we just pull back magnet out of the solenoid. So explain what happens to the ammeter reading as the magnet moves out of the left hand of the solenoid. If you just move this magnet in backward direction,
So reading will be same.
reading will be same. Okay. Any difference that you observe?
Like the pole of the solenoid near will be the south.
Okay. Or any other change that you find out over there with respect to direction?
Uh,
Because we
like the
discussed.
magnetic fields, they turn.
Yes. So basically, if you remember, that reversing the magnet will reverse the direction also, right?
Yes, sir.
Basically, uh, there are two situations. Stops inside the solenoid and then, so you explain the concept like this. When solenoid or the magnet,
I'm going to explain for inside and outside also.
okay, inside means if you just consider the example. So the first one shows you the concept of that magnet is moving inside. Okay.
Okay.
Second arrow shows you that magnet is moving towards left hand side. It means we are taking out of the solenoid. Okay. Taking away from the solenoid. We just mentioned when the magnet moves inside the coil and stops. So ammeter will show no deflection. And the second part is when magnet is pulled back, so the deflection,
Side scenes.
yes. So basically your magnitude will remain same, but your direction will be reversed, right?
Yes.
So when magnet stops in the middle, so there will be no value of an induced EMF. And when you pull back, so during that pullback situation, you will get uh, EMF, induced EMF in opposite direction. Okay.
Yes, sir.
So this is the simple concept. If you have a question, consider any other question. Let's find that one
Uh,
also. Because mostly questions are now related to electromagnetic induction. Okay, now consider this question. This is related to electricity and electromagnetism.
okay.
So first, observe the diagram, right? There is a main supply and a motor is connected, and there are two contacts at some gap. There is a gap between them.
Yeah.
So it means your circuit is incomplete right now. Okay.
Yeah.
And when just you turn on the main, so due to that magnetic field, because there is iron coil of wire over there, there is also another battery, there is a source, sorry, there is a switch over there. Basically this S is not over there, it should be at switch point. So remove S from here. S is actually this one. So when you just complete this switch circuit, right, the second circuit one, and if you consider this one as circuit one, so when you complete your second circuit, so definitely it will connect, and this,
But how will the first one will work? Like there's no
yes,
like a
basically
switch.
it works on the second with the second circuit. Okay, when you just connect this switch, so electric current will pass through the coil of wire, and you know when electric current passes through the coil, so there will be magnetic field. Okay, and when
Yes.
there is a magnetic field, so definitely it will attract iron armature, right? And that iron armature will be attracted towards this iron rod or
And yes,
coil of wire. Okay, and you can see there is
yes,
a
yes.
pivot. It means it will act like a seesaw. When one
So
side is,
the gap will be closed then, yeah.
yes, and this will move in upward direction, and these gaps will be closed and there will be no gap, and these contacts are in contact with each other, so your motor will starts to work. Okay,
Oh,
and there is an insulator, so these contacts are completely separated from each other. Okay,
oh.
any confusion?
No, no.
So this is the complete circuit and the working, right? Because
So
there.
if
Hmm.
so if the second one doesn't work, the number one will also the second one will also not work, or they work.
So that is the main thing, right? Because you can see
No,
these
will it
contacts.
like
Basically, if you just make complete the circuit one, so you have to forcefully connect the contacts, right? But we have a
yes,
proper
yes.
setup, right? When there is a supply and when there is a switch, so with the help of electromagnetism we can use this concept, right? Because in question they
Okay.
mentioned shows a simple relay used to switch a main electric motor. This topic is no more included in theoretical science in our syllabus, but just for the reference of question, we can solve questions like this, right? Because this will
Okay.
give you the idea how electricity produce the magnetic field and how that magnetic field works in circuits and in different applications. Okay,
Okay.
that is the same question they are asking. Explain why the motor switches on when switch S is closed. So they are asking about this switch.
Okay. So like
So you already know the process we discussed when we just
yeah, yeah.
switch on.
Okay. But it says why does it switch on when the switch is off?
Okay. So basically when the switch S is closed, the meaning of closed is this is open, right? You can see there is a gap. So when
Yes,
there
yes,
is a gap, so that will give you the concept of open.
yes.
And when you make the contact between them, so now it is closed.
Oh, okay.
So this is the concept, right?
Yes,
That's why diagram is important to understand that what is the concept of closed and open. So when your switch S is closed, so your circuit will complete, and electricity will pass through the coil of wire, or you can say that current will,
awesome.
yes, from coil of wire, and this core that is made up of iron normally, So core will be magnetized.
And it will close the gap.
Yes, and it will attract the iron armature, it will attract the iron armature. And as you can see, due to this pivot point,
Yeah.
an armature just complete the contact between circuit
Yes.
and motor will switch on, right?
Yeah.
And the second thing is why the core is made from iron rather than steel.
So for like better conductivity and like actually,
Okay, and if you remember, we also discussed that if we use iron, so iron can easily be magnetized and easily demagnetized, right?
yeah.
We discussed somewhere, that is in the other notes. So
Yeah.
basically,
Yeah.
iron can be easily magnetized because that is like a temporary magnetic material.
Temporary. You can write it's like temporary magnet.
Yes, you can also write that it will act like a temporary magnet. Okay,
Okay.
right. So this is the difference.
Okay.
Okay, and the third question.
Like why the relay is better using than the motor?
Yes, they are asking, suggest one reason in some situation using the relay is better. A student suggests that the motor can be turned on and off without a relay because we know we can easily just turn on and turn off the motor without the relay, right? There is no need of relay over there, but still we are using relay over there. So he suggests connecting the mains to a simple switch in series with the motor. So suggests one reason why in some situation using the relay is better. So what do you think that why using the relay will be better in the case as compared to the direct connection with the motor?
Um, it will like provide more power.
Basically it will give you like a safety purpose, right? Because if you connect the direct motor, okay, so if you connect with, so if you just directly connect motor with the mains, so definitely if your voltage will be high or low, so that will definitely directly affect your motor, right? But if there will
Yes.
be high voltage and low voltage in the relay, right, so they automatically just release the pivot, and motor will automatically turn off, right? So
Yes.
it will act like a safety one. Okay.
Uh, so if the voltage is a little more, then it will automatically work.
Because if your current actually increases, so it will just only completes your circuit, right? It will
Yes.
not affect, because there is no direct connection with the motor. There is direct connection with the iron core, so it affects the iron core, right? Because our main purpose is to just make the contact, right? So that only acts like the switch. Okay, so basically it will provide you the safety one. Okay.
Yes.
If there is another question related to the diagram, you may read the question, then I will zoom in.
Okay. So there's a magnet in this one also.
Basically there is a cardboard tube, and on cardboard tube we are having a coil of wire. This is just like the
Okay.
solenoid. So when current passing through the coil, right, so it will generate magnetic field, right, just like this concept,
Yes. Yes.
the right hand rule, where it is. Yes. Okay. So with the
Yes.
reference of this idea, you need to draw the diagram and draw the pattern of the magnetic field inside and around the coil. Mark the direction of this magnetic field. So first of all, what do you think that which side shows you the North Pole or South Pole?
And like the up show towards the left shows the
Yes.
north pole,
What will be the pole on left hand side? What will be the pole on right hand
north
side?
pole, and the other south pole.
Okay. So if you compare with this diagram, in this diagram, you can see current is moving in upward direction on right hand side.
Yes.
And in this diagram, current is moving in downward direction. So if you use your right hand rule, so with the help of right hand rule, so your North Pole will be on right hand
Right
side.
side. Yes.
So this will be your North Pole. This will be your South Pole. And you know that magnetic field will move from north to south.
Not the
Okay.
south.
So we will make field like this, and the rest of the field are like, okay.
Oh.
So this is the diagram of magnetic field. And mark the north pole of the coil. We already marked the north pole.
Yes. Yes.
Right side will be north,
Left side.
left side will be south. One more question.
Okay. Like permanent magnet, they can provide a larger current.
Okay, so basically in question they are asking describe how a permanent magnet is used to produce a large reading on the ammeter and the supply of current to the coil is removed. So basically there is no supply connected with the coil. The ends of the coil are connected to a sensitive ammeter. Describe how a permanent magnet is used to produce a large reading on the ammeter. So basically you have to explain a process because there is no electric source connected, right? You have to generate reading on ammeter with the help of this process. So what do you think? What we need to do?
Like
Basically, there is a concept of permanent magnet, right? And you know, if you use the permanent magnet, so what will happen?
I like they have a stronger
Uh,
magnetic field.
yes. So basically, we have to take a magnet over here like this. And if you move that magnet into the field, right? So that will be the same situation as we discussed before. Okay, because there is no electric source connected. So what we need to do, have to move one pole of the magnet inside, outside of the solenoid with high speed because they ask large reading.
OSC
So for large reading you have to move with greater speed, right?
faster.
Yes, that will induce an EMF in the coil and
Increase the current.
yes, that will deflect.
Different I mean like sure reading, right? Like,
Yes, because you know in meters there is a needle just like speedometer.
yeah.
It will deflect because when you are moving the magnet, right? So at that moment you will get the value of induced EMF. Otherwise there will be no EMF induced in the coil with rest mode movement, right? Okay,
Yeah. Okay.
so this is the concept.
Oh.
And explain why a current is produced in part 1. That is also simple.
Because like when you move it with a higher speed, there's more current which will pass through.
Yes, and there is one more important term that we used to write in previous question, due to.
The flux.
Yes, so basically change in magnetic flux linkage in the coil
Yeah.
inside the coil that will induce
Yeah.
an EMF because of electromagnetic induction,
Yeah. Induction.
right?
Yes. Yes.
So these are some questions related to the magnetic and electricity concept, that is electromagnetism, that we discussed, right? And
Yeah.
from next class, we will start the concept of uh, electromagnetic induction, in the sense that how to produce the force using electricity and magnetic field, right?
No.
Okay.
Okay.